All right. Hey, hello. Oh, yes. Yes, yes. Oh, my goodness. My goodness. Thank you for being here. That is so awesome of you. Hitting the play button. Turn that up. You can turn that all the way up because I love that. You know, I love that. It's great to have you here. Brothers, sisters, intelligent, beautiful peoples that love to learn. I love people that love to learn. Yes, I do. Yes, I do. We're just going to get right into it, guys and gals. It's a blessed, beautiful day. I'm telling you, it's a blessed, beautiful day. Ah, yes, I have hope. I have hope for the future, and that makes me feel better. It definitely does. Let's go. I'm just gonna turn the music up in my just hold up. I want to check my sounds here. Just one sec, guys. That looks good. And that looks good. Okay. All right. Thank you for your patience. Appreciate that. Okay. Well, I guess we're going to just get straight to it. Let's get straight to it. Yeah. Flick that switch in the old brain molecules. Well, whichever, whatever. Just flick the switch because we're going to do some math. Let's go. You guys ready? Are you guys ready? Oh yeah, I'm such a good mood today. Yes. Good mood today. All right, so we're going to continue. I'm kind of thinking of like I know I've showed you guys when we're working with percentages, so stay tuned. It's great to have you here, truly is. Those of you who have been following and watching, you know, you're the first 10 viewers. You guys are awesome. You truly are. Dedicated and committed. I love you guys. Okay? All right? Just letting you know. All right? You give me hope. You give me hope. All right? Hope is good. Hope is good. I've been working on percentages, and I kind of have this one way of doing it. Just I'm kind of showing you, I guess, the long way, if you will. My main goal is to kind of simplify things and make it easier for you guys and gals. That's kind of the goal. I have another way of doing percentages. I was thinking of sharing it and showing you. So there's another method. I guess I could kind of show both methods again. I don't know. To be honest, I'd just follow the series. We're kind of doing a mental math series, okay? These are just random questions. A lot of them could be kind of things you have to work out before let's say you're working on a math problem. You might have to actually get some information and do some basic calculating to so that you can have a value or whatever, so that you can continue using that value for the rest of your calculations, if you will. Okay, I know that was kind of long, but let's make math fun and easy, okay? If you love counting money, you love numbers. What else can I say about it? Quick drink of coffee, and we're going to get going. I should make sure the stream is going well, but I think it is. Excuse me, guys, gals. Just gotta make sure. I'm my own mod here, so I really don't want you guys not hearing me. What? Okay, here we go. Alright, sounds like it? Good. Alright, perfect. Okay, I think we're golden. get to work now. Okay, so here we go. Did I do this one? No. So let's get going, okay? You take swimming lessons 4 days out of 5. Wow, that's pretty good. You're going to be a pro before you know it. What percentage does this represent? Okay, I think I could show you the quick way. Yeah, I think this is gonna do it. This is gonna do it. Okay, so here we go, guys. Now I recommend, like, I know a lot of this might be easy for you, okay? A lot of it's pretty basic stuff, but it's, kind of it doesn't hurt to do these simplistic problems if you think it's simple. Just keeps the mind fresh, guys, right? It's good for the old brain. Exercising the brain is good. Okay, I believe that people, even, as you get older, right? I guess I'm a bit, up there in age, I guess. I don't want to age myself too much, but I think it's good for the brain just to continue exercising it. I hope you follow me. Like, this is kind of what I don't have any proof. I can't prove this. I have no statistics. But I think if you exercise your mind, maybe it could be reading. Just simply reading might be enough to do it. I don't know. Mathematics for me, I feel I'm exercising my mind. And I think my theory is, if I do this, knock on wood, I'm avoiding Alzheimer's or whatever, or some timers, or all the timers. I'd rather avoid that. So I think exercising the mind is good. If you're not, then yeah, I don't want to go on a tangent, but yeah, I just, like, you're almost not existing. You're not really existing if you're not exercising your mind. So I think it's good for you. Okay, so don't resist it. Enjoy it while you're young, right? And then years later, you get older, or whatever, you can get back to it, and it's just like riding a bike, guys. Okay, anyways. All right, back to the problem. So before we've had problems such as, this is going to be our example, okay? We're going to get right to this. So what I would show you, the question would be, convert this to a decimal, right? And you don't really have any way of doing it. You'd be like, oh, what do I do? How do I convert this to a decimal? I don't know what 4 divided by 5 is. Oh, the humanity. Right? There are ways to figure it out, guys. Okay, so this is the way to do it. Remember how I was saying 100 is the magic number? Because it really truly is. When we're working with percentages, right, everything's out of 100, essentially. You have 4 questions. You have 5 total questions. You get 4 of them correct. This is how you figure out, your percentage. And we basically just multiply it by 100 or 100%, right? Okay, with that said, again, recall, right? Every whole number, we don't write it this way, but technically it's a numerator, right? Okay, we're just kind of going over the basics, right? A lot of you are going to know this stuff, but a lot of you may not know it, okay? So those of you that know, just please have patience and understanding, all right? Thank you. You're awesome sauce. Okay, numerator, right? And obviously below is the denominator. So we need, like, what I call it the magic number. It's not really the magic number, but we need that number that we can convert to a decimal, right? So this is what we do. Okay? This is the step or the way that I've been showing you. which works. Okay, it works. I'm going to show you quickly this way, and then I'll show you the other way. So you can kind of pick whichever one you like the best, okay? So here we have to reduce. I recommend do your reducing right from the beginning, because if you do all your multiplication, you're going to have 400 over 5, right? If you just straight go right to it, okay? Well, you still have to reduce that, right? Okay, you're making more work for yourself. Don't do that. No. Right? Factor ahead of time. So let's make what we want. Ideally, we want the denominator to be 1. Now, it's not going to be 1 all the time, you know. Sometimes the denominator is going to be 3, or it's going to be 5. Any number that we can't reduce anymore, right? Of course, if you have 2, it just depends if you have an even number on top, right? You need an even number to be able to continue reducing, right? So, anyways, with that said, you understand, right? So, I recommend we reduce right now. So, just kind of do, I guess you can, I'm not sure what to call it, kind of brainstorming some numbers. We know 5 times 1 is 5, and we know 5 goes into 100, right? But we're not sure how many times. How many times does 5 go into 100? Well, we could do the long work. Whoops. Right? We could do the long work. Or we could, well, probably the easiest is the long work, because we know, like, we could sit here and actually I'm going to leave that. We could sit here and go, well, we know 25, 25, 25, and 25, which is essentially 25 times 4 equals 100. We know this. Another way you could do it is, well, I guess you could go, well, 5, 10, 15, 20. Ooh, that's 20. We could take all these 5s out, right? And then make them all 20, right? That would be one way of doing it. Then we would go 20, 20. That would be our answer. We would get it, right? That would work. Okay, now we have 5 times 20, right? And that's the number we want, right? Because essentially it is 20. I could do the long work, right? We could break it down this way and try to figure it out. That's one way of doing it. We're kind of brainstorming here, okay? So now let's do the long division. I know a lot of you guys are probably not fans of it, but it doesn't hurt to keep, long division is one of those things that's easy to forget how to do if you don't do it for a long time. Okay? Because, let's be real, you resist wanting to do them, so it's not one of those things you care to store in the old memory banks. Anyway, so it can be easy to forget. So the way I kind of teach my kid, I go, does 5 go into 1? Well, it does, but you get a decimal value, right? You would essentially have 1/5, which is 0.2. Okay, it's not really what we want. So we go to the next number. Okay, does 5 go into 10? Yes, it does. How many times does it go into 10? Well, we know 5 times 2 is 10, right? I'm going to try to be quick here. I'm trying. Okay, so I'm going to go 2 up here. I'm going to put 10 here. And again, when you're dividing, it's subtraction. So we get 0. Then we bring down the 0. So essentially, we're bringing down the 0. Well, what's left to do with the 0? I don't really have the best explanation for this, but just essentially just take the 0, put it up top. What else do you do with it, right? Because it does exist, and yeah. So there we go. And plus we know 5 Well, that wouldn't be the answer anyways, just 2, right? Because we know 5 times 2 is 10, right? So obviously not the answer. So, okay, so this is over 1. I don't know what happened there. All right, so 20 is the answer. Okay, I know that was a little bit of, took a little time, but that's what we want. That's what we're looking for. So, to show the long work, eventually I'm going to get to the point, guys, where I'm not going to show all these extra steps. I'm just going to kind of skip it, right? And what I mean by the extra steps is showing, like, I call this pulling the meat off the bone, right? And the reason I say that is you want to find the largest number. You want the largest number here, because doing that, then you have less to reduce at the end. If you find the largest number, you can reduce twice if you want. It's up to you. But if you find that largest number ahead of time, of course 5 is already going to be the largest number, right? Because essentially we're going to be taking this to 1, right? That's kind of what we want. So we're breaking this into 2 parts, right? The 4 here is just going to hang out for now. We're going to break this 100 down. That's what we're doing. And as a matter of fact, I'm kind of writing this wrong right now. Okay, this is supposed to be 1. Okay, so this is the 5 here that essentially we're going to be getting rid of. Okay, that's what we're going to be canceling. So what times 5 gives us 100? Well, that's 20. We're just really breaking it apart. We're breaking that 100 into 2 parts. That's what we're doing, guys. It still means the same thing, right? We still have 4. 4 is just hanging out. This 5 we want to delete. We want it to be 1, right? Like I said. That's the goal. Get our denominator to equal 1. Okay, so this here, these 2 are going to cancel each other out, right? Because 5 divided by 5 is equal to 1, right? Anything times 1, right? You don't really need to write it. I don't need to write times 1 again. It's redundant, right? So essentially that's what we're doing. We're breaking the 100 in 2 parts. And this is factoring, guys. Excuse me. Okay? This is factoring. So 4 times, now we just multiply. We really can't reduce anymore. Now we're down to 1, right? So we're at the point, just to show you, we're at 4 times 20 over 1. That's what's left. Okay? And of course, we're going to get 4 times 2 is 8. We're going to have 80. Okay, that's the number we want right there. This is the number that's giving us the percentage. Essentially, that is the percentage. And I should explain that. I'm not really explaining that because really what we're doing is multiplying the fraction by the percentage. Okay? And that's actually the answer. That's the answer right there. We're actually done. Okay? We're actually done. And that's how you do it. Okay, so I'll just go like this. Blah, blah, blah. That's kind of a little bit messy, but anyways, there it is. Other thing I was thinking of as well, let me just show you quickly. I'll just go 3/4, right? Another way I was thinking of doing it was making this 100 to get that fraction, right? We want the top and bottom to equal to 100. Well, not really, but the goal is to figure out, okay, so we know 25, I'm going to see if this works. I was just kind of thinking of some other way we could do this. I'm just kind of, I guess, kind of being a mathematician a little bit. Making this 100, right? So 4 times, I wonder if this will work. 25 times 4. So what times 4 gives us 100 is 25. I don't think this is going to work. What times? No, that's not going to work. I'm thinking out of the box a little bit, but I don't think this will work. So I'm going to backtrack, okay? Because I don't want you guys getting confused. I'm going to have to think about this a little bit more. I thought maybe I could get that 75 just by, well, really I am multiplying by 100, but you want it to be the numerator. So the works down here, of course, we'll get 100. I know, I need to stop. I'm just trying to think. I should have kind of worked this out before I start talking about it. So we need 75 here, but that's not really gonna work. So that would be, oh, right. Aha, now I'm starting to think about it. Okay, it kind of came to my mind. I don't know if I was dreaming about this or what I was doing. I'm like, well, what if I do it this way? Because we know that 3/4 equals 0.75. Really, that's what we're looking for. We need that 75. Okay, it's the same as saying 75 divided by 100. They're the exact same answer. Okay, guys? What we're doing really is we're making this, we know the magic number is 100. That's why I started here, because I know 4 times 25 is 100. So now thinking about this, well, if I multiply the bottom by 25, I have to multiply the top by 25. That's how I'm getting that. I started thinking about this. This actually kind of works, right? Now, it is a lot more simplistic for sure. What if I went, what else go? Let's see if that works with 4/5. Let's just see. That might be the quickest, fastest way to do it. And then at this point, you know that you're just doing decimal hopscotch, right? You know, you crunch enough numbers for a while, you start kind of figuring math out a little bit, right? Okay, so we want to make this 100. That's the goal. We want to make the bottom 100. Well, we know 5, we've already done this. We know 5 times 20 equals 100. So we're multiplying the bottom by 100. Therefore equals what we do to the bottom, we have to also do to the top. Right? That actually works. So then we get, this is actually pretty fast. This is what I wanted to show you guys and gals, but I was a little worried it might not work. And it actually does. It's crazy. That's pretty fast and simple, right? Before, what I was doing, right, so just to show you guys and gals the difference, right, I better leave that. What we were doing before, again, this is method 2, you can call it method 2, and this is method 1. Okay, method 1, I was going 4/5, and the magic number being 100. Well, I'm multiplying the top by 100, and then I'm factoring and reducing, right? So essentially, we're gonna get 4 times 20 over 1, which gives us 80, right? That gives us the percentage automatically. That's what this does. Okay, you following along? The first method gives you the percentage, right? Because we are technically speaking multiplying by 100%. Okay, here in method 2, we're basically making the denominator 100, right? So we figure out what times, I think, you know, obviously the number has to kind of be divisible by 100, right? It has to be able to divide into 100, right? It kind of works if you know, right? Following? 5 goes into 100. That's kind of what I mean. The number has to actually work with 100. Okay, so what I'm doing here in the second method is essentially I'm going, what times 5 gives me 100? Well, that's 20. Okay, well then what I do to the bottom, I have to do to the top. Okay, this here, right here, gives us the decimal. So I guess really that's the difference between the two. The first method gives us the percentage, and the second one gives us the decimal. So that would work. So you can use both. So this would be, I'm sorry, I ran out of room here. This would give us the percentage. Oh, sorry guys, I kind of ran out of room here. Okay, this will give us the percentage, and this one gives us the decimal. Now, if you can remember both methods, that's great. Okay, we can still turn this to a decimal easily just by dividing by 100. We can go, at this point we kind of go from here to here, essentially, right? From this point we go to here, and then we'll get our decimal. Okay, so step 2, right? Okay, I hope that helps, guys. I hope that helps. So there it is. Pretty awesome sauce, right? Let's drop in some yays and we're going to carry on. All right. Next question. So that's the answer, 80%. Okay, a basic calculator has 6 rows and 5 columns. Let's see. Let's look at a basic calculator. I do have an image right here. Okay, what does it say? It says 6 rows. 1, 2, 3, 4, 5, 6. I have 7. 5 columns of buttons. 1, 2, 3, 4, 5. Wow, here it does. Here we have 1, 2, 3, 4 rows. 1, 2, 3, 4. Well, I don't know. Let's not overanalyze this, okay? Let's just use the example. Keep it simple. Keep it simple, Stanley. Okay, KISS method. So, they're saying 6 rows. Okay. I don't know. I guess I could draw this out. It's gonna take a little bit of time. So they're saying 6 rows, and in each row, and 5 columns of buttons. Okay, 5 columns. Okay, columns are vertical, rows are horizontal. Okay. Okay, so it's just a matter of going 1. It's not going to be perfect, guys. I'm trying to kind of go through this quickly. But you get the idea, right? One, 2, 3, 4, 5. We need one more. 6 rows. Don't want to mess up. This is kind of, if you're a visual learner, again, guys, everybody kind of learns at a different, I don't know what to call it exactly, but there are visual learners, There are, I guess you could call them physical learners, where they have to touch and feel. And then you have those that learn by hearing or listening. Okay? Of course, you heard the term great listeners. That's those individuals. Okay? So visual learners, those that learn by feel and touch, and those that learn by listening. Okay? We all have our strengths and weaknesses. We're all designed, you know, yeah, without getting too, but you get it, right? So you understand, right? Not everybody learns the same way. Okay? All right, so it says we have 6 rows and 5 columns. Okay? How many buttons does it have in total? Okay, just like when we're doing area, guys and gals, right? When they were doing the square units thing, it's kind of the same thing, because essentially we could look at these as square units, but I don't have them drawn together, right? They're not physically against each other, right? But here's the quick math. Okay, you can count them if you want. You could, right? But here's the fast math. Count how many are in a row, count how many are in the column, and just go. Okay, so I go 1, 2, 3, 4, 5. Oh, there's 5 in the row. I wrote that wrong, didn't I? Yeah, I did. 6 rows, 5 columns. My bad, guys. Just seeing it now. We'll fix that up. Okay, you're probably like, you wrote it wrong. And you are correct. I did. Okay, 32. Take the eraser off. So, what? Hold up. Did I write that wrong? A basic calculator has 6 rows. 1, 2, 3, 4, 5, 6. What's right? What am I doing, Bob? What am I doing? Okay, I know what I'm doing, because I'm counting how many are in a row. That's why I'm throwing myself off here, guys. We still have 1, 2, 3, 4, 5, 6 rows. We still have 5 columns. That has not changed. Myself, I'm counting how many are in the row. That's why I'm throwing myself off. Anyways, you can still do that. We can go 1, 2, 3, 4, 5. Okay, there's 5. 1, 2, 3, 4, 5, 6. There's 6. Okay, essentially we would have a 5 by 6 area. Okay, still the same thing. So just like area, it's no different. That's a quick way to do it. You don't need to count it. All you need to do is just count how many are in the row. 1, 2, 3, 4, 5. There's 5 in the row. 1, 2, 3, 4, 5, 6. There's 6 in the column. Okay, so 6 times 5 is obviously 30. Okay, so the answer is, how many buttons does it have in total? It's 30. Pretty simple math, right? But the main goal is to kind of show you, you only really need to count how many buttons are in the row, how many buttons are in the column. Boom shakalaka. Multiply the two numbers together and done. Okay, next question. 3 students receive their marks for a project. Okay, all right, 3 students. We have 3 different students. Okay. Sorry that I'm writing so quick. Just trying to speed things up. I kind of watch my videos and I'm like, maybe I'm taking a little too long on some things. So I'm trying to put it in another gear. Okay, 3 students received their marks for a project. Jane found her mark as a decimal. Okay, so Jane. I know a Jane. She's awesome too. Okay, and Jane found her mark as a decimal. So her mark as a decimal, 0.62. Now, if you guys are good at fractions, you'll already know what that is. I already have it memorized, so I know what it is. Okay, we're just missing the 5, that's all. Okay, but I'm going to go like that. I'm going to get rid of it. Let's pretend we don't know. John calculated his mark as a percent, okay? Okay, his mark is 73%. Okay, and Jean, they went with all the J names, huh? That's fine. Got 12, so actually, the way it's written, that's kind of the female version of the name, and then there would be the male version, which is written like this. They're said the exact same way. Okay, anyways, Jean got her, I'm going to assume her, hers is 12/16. Okay? Alright, who got the best mark? Now, a lot of you might already figure out that John has a higher mark, right? If you're logical thinkers. Let's convert the decimal to percentage, right? Magic number is 100. Again, just like I've been explaining to you guys, right? Here's the quick way to do it. When we're converting to a percentage, you go to the right. Okay, just remember that. If we're going to a decimal, you go left with the jumps. Okay? So we're going right with the jumps. That's kind of a little tip. So you can write that as notes in your head, somehow store it in your memory banks. That's what you do. And if you look at it, we're really taking this to a whole number, right? That's what we want. We want the decimal to be there. So that's pretty easy to figure out. We need to go to the right. So 2 jumps. Essentially, we're going to be multiplying this by 100. Okay, to get that value. When you multiply it by 100, you're making the decimal jump twice. Again, the magic number is 100. 2 zeros, that's how many jumps you do. 2 jumps. 2 zeros, 2 jumps. So, I'll just write it here. So, Jane is 62%. Okay? All right. Good effort, Jane. It's still good. Okay? Still good, Jane. All right. John's doing pretty good. Decent mark. So now we got to figure out what Jean's mark is. So it's just a matter of, we can reduce the fraction, right? I know you guys, don't be scared of fractions. They're really not that bad. Okay, so we got to find the common number, right? So that's why we got to study our times table. Okay, this is the reason. 3 times 4 is 12. 4 times 4 is 16. Our common number is 4. Okay, so 4 is the number, the largest number, the most meat off the bone. Three and 4. Essentially, we want to cancel some numbers, right? That's the goal. So we're left with 3/4. Okay? I'll write it out, but there we go. Okay? I'm trying to be a little bit faster here, guys. Okay? Don't mind me. I know. It's alright. Positive mind, guys. Here learning. Okay, so it's 3/4. Now we need to turn it to a percentage. We've already done this in numerous times. The quick way to make it a percentage, right? Let's do that. What times 4 gives us 100? Right? Think of it as like money, right? You know, a quarter is 25 cents. And you know, it's 4 quarters that makes $1. Okay, I'm trying to instill in your guys' beautiful young minds, your young learning minds. It doesn't matter where the decimal is. The decimal is just like a position on numbers. Okay, we could go 25 times 4 gives us 100. We could go 0.25 times 4, well, essentially gives us 1. But we still have 1, we still have 1. The zeros are kind of just fillers, really. Okay? But this is the pattern, like I'm saying, trying to say to you guys and teach you guys. Numbers are consistent, they have patterns. And you'll see when you work with numbers enough times, grinding numbers, you'll start seeing patterns in numbers. It's pretty amazing. Okay? So they're the same numbers, just they have the decimal in a different position. That's all. Okay? So you say in your mind, well, it's 4 quarters that makes $1. Well, it's no different than saying 4 times 25 equals 100. I could put a decimal here and I could put a decimal there. That's still quarters, that's still $1. 25 times 4 is 100. Okay, so 25. We're going to do it the same way. So when you multiply the denominator by 25, you have to multiply the numerator by 25. Okay, and that's going to give us 75 over 100. Okay, that's the number really that we're looking for right there, that's 75. Essentially, that is the percentage right there. If we do the math here, we're turning it into a decimal, okay? So it looks like Jean is the winner chicken dinner, okay? She gets the all-day breakfast chicken buffet. Lucky day for her. Okay, so just gonna remove all that, and then I'm gonna put 75%. Okay, Jean, and that is the answer. So that was some pretty good examples. We could have still did it the other way too. Like we could have took the 12/16, reduced it to 3 quarters. We could have did it, you know, like I've been explaining to you guys. I'm just gonna say this quickly, right? I have like method 1 and method 2. The first one gives us the percentage. The second one gives us the decimal, right? I guess technically speaking, we would have probably done it this way, multiply by 100 over 1, right? That would be the right way to do it, and then just factor, and then we get 1, we get 25, and then basically we get 75 over 1, which equals 75, right? So it just depends on how your take, the angle you approach it. Bottom line, that's what you want. That's 75. Okay? Alright, let's leave it at that. And I meant to write students. My bad, guys. It wasn't plural. Okay, next question. If Okay, 0.333. Now, they only draw a singular line over the last digit. If this equals 1/3, okay, which it does, then what does, I'm just going to write then, good enough, 0.666, I always like to write 7. That's not really the repeating value, but what does that equal? Okay, so the way we can look at it is two ways, I guess. We can never really thought about how to approach this, but one way I thought of doing this is you look at these decimals and you go, what's the kind of the common thing right here? What is kind of common between the two? Well, not really common, but we need some matching numbers, right? We say to ourselves, well, we have 3, we have 6. What times 3 gives us 6? Well, that's 2, right? So this is supposed to be a 6, but I just write it like this. It all kind of means the same. Essentially, this was rounded up. That's all. So between all of these is 2, right? So I'm thinking, well, what if we take this fraction and just multiply it by 2, right? Because we essentially want to multiply it by 2. That work? Let's see. Okay, so essentially, again, remember a whole number 2 means 2 over 1. I love multiplying fractions because it's a lot easier than adding and subtracting it, okay? Just gonna say that, just generally speaking. You have to do a little bit more work, okay? Finding that common denominator when you're adding and subtracting fractions, right? The denominators have to match, okay? But not with multiplying, okay? They don't have to. We just straight multiply. Straight multiply the numerator, straight multiply the denominator. So awesome, okay? 1 times 2 is 2. 3 times 1 is 3. Okay, that's, for me, that was the fastest way to figure it out. And that is the answer, 2/3. For me, that was kind of the most logical angle or approach to solve it. Okay, there are ways. Now, it's been a minute since I've done this. There is a way to actually figure out how to convert decimals to fractions. Okay, there is. But I can't really recall. I mean, like I said, it's been a minute since I've been in college. I used to be able to do that. But again, it's one of those things I kind of, it's in the memory banks, but I'm trying to recall and remember how to do that process. I just can't recall off the top of my head. Okay, let's continue. How are we doing for time? Yeah, we're getting up there in time. Okay, let's, come on. Okay. Let's do another one. What value represents, 1% of 400,000? Okay, and this is financials, so Man, excuse me. Okay, guys, help me get to 400,000 and I'll start gifting out prizes and money to, I'll have to think of a way to do it. But I would gift. Definitely. Hit that like button, support the channel, share with your friends. Remember, sharing is caring. That's how we grow. Okay? It would be great to see more people interested in learning. Okay? Get away from the drama and the toxicity on the internet. It's just not good for you. Okay? There is good stuff on the internet. I will admit that. Okay? Or even on YouTube. Okay, I watched some stuff today I'm not going to get into it, but it actually made me feel good, and it told me, wow, the world, the future of the world still has a chance. So that was promising for me. Okay, how do we do this? 1% of 400,000. How do we do this? Well, 1 divided by 100. We have to kind of get some zeros here. We need to figure out some jumps. 1% of 100 equals 0.001. Is that correct? I'm kind of just thinking of it randomly in my head. 1 divided by 100. 0.01. I went too many zeros. Oh yeah, one, 2 jumps. It's always to that. Yeah, that's what it is. You stop right at the right side of the actual number. So, and plus I know it's 2 jumps. Getting carried away, guys. So that is 1 out of 100. So, that would still work, would it not? 1, 2 jumps. That might still work. That is really the only logical way I could think of doing it. Now, to show the work, maybe this would work. 1 out of 100 equals, or no, multiplying times 400,000. This is the other way I'm thinking, so that I could cancel zeros. Remember how I was showing you guys, like if you have something like this, you could actually cancel zeros. Oh, did I not write enough? I didn't write enough numbers. Let me just write one more here, okay? There we go. Okay, boom. Right, there we go. That's another way of doing it. So, process 1, process 2, however you want to look at it. Again, essentially, it's still 2 jumps, right? We just got to figure out how many jumps we need to do with the decimal. And the answer, in fact, is... You could do it on your calculator if you want. Essentially, you're going to be doing that. You're going to still be going 1 divided by 100 times 400,000. Okay, without using the calculator, this is how you show your work. And yes, you can get away with canceling zeros. It's kind of like reducing, but you're not. Well, you are. Yeah, technically speaking, you're reducing. So if I went 400, 1, 2, 3 zeros, divided by 100, I get 4,000. Dropping the yays. All right, guys, gals. Trying to finish up here. Okay, you receive a commission of 20%. Okay, you're a salesman. Your commission is 20% of your sales. Okay, now you should know that again, 100's the magic number. 20 divided by 100. I could cancel zeros here too, guys. So I have 2 over 10. Reducing that. Well, we know that 2 goes into 10. So if I'm the most meat off the bones, I'm going to pull out a top and the bottom is 2. So I'm left with 1/5. Okay? Which equals 0.2. Okay? I'm going to actually clean that up here. Okay, again, it's the same thing. We're converting to a decimal, therefore we're going to the left, 2 jumps. 100 has 2 zeros, 2 jumps. Our answer is going to be 0.20 in a decimal form. Okay, so you sell 15,000 of goods. Ooh, okay, that's quite a bit of sales. Okay. So they get 20% of this value, right? 20% of this. Okay, what's the commission you receive? Okay, excuse me, guys. So I've already kind of reduced. I've already reduced this 20%. Excuse me, hold up, guys. Excuse me. The itch in the throat. Excuse me. I don't know what to call that. It's almost like you have like a hair in the back of your throat or something weird. I don't know. I hate it. I know hate's a strong word. I strongly dislike it. Okay. 15,000. Okay. You understand what I've done so far? I've already reduced this to 1/5, right? 2/10 is 1/5. Okay, that's where that comes from. So we have to basically divide 15,000 by 5. That's essentially 20%. Okay, so now here's the trick, guys. Okay. I'm showing you this. Just ignore the zeros for now. Okay? Just ignore the zeros. Right? It doesn't matter if you have 10 million zeros, right? 5 still goes into 15. Okay? So it's just a matter when you ignore the zeros, just ignore them. 5 goes into 15 how many times, right? 3 times. Okay? So to reduce, if I'm to show you the work, it means 5 times 1 and 5 times 3. Okay? 5's cancel. You're left with 3. Okay? Right? Because 3 divided by 1 is 3. Okay? Now don't forget your zeros. It's just a matter of bringing your zeros now. 1, 2, 3. That easy, guys. Okay? Just gotta make math simple, guys. Make it simple, right? If it has 1 million zeros, just ignore all the zeros. All right, but you do have to be careful, you know, if you have an extra zero here, right? We got lucky because we have 3 zeros behind the comma. We're fine, right? We are fine. That's the answer. Easy math. That's showing you work. And that's how quick that is. Okay, last one, guys. And then I'm going to leave you with another problem. And then I'll see you guys in the next video. But let's do another one. Or maybe this could be the one I leave with you. I don't know. Depends how fast I get this. Okay, Carol sells $2,400 of hats. So she sells hats. Okay? She has $2,400 in sales. Okay? That's a pretty decent day. So so each hat each hat costs this. Each hat is $40. Okay? I don't know if that's too expensive. Maybe there's summer hats, you know, them girls. I'm not saying anything bad. The girls, they love them summer, spring type hats, right? It's very nice, you know, on the ladies. So they're $40 a hat. How many hats did she sell? Okay. Simple math, right, guys, gals? So if you have, let's say you had, let's say you sold 5 hats, okay? What you would do is you'd be going forward. You would, let's say one customer bought 5 hats, okay? You would be going forward and figuring out the total, right? I could do the long work. 40 times 5, that's 0. 5 times 4 is 20. So $200, okay? So we know our answer just from doing some quick calculation. We know that it's going to be a lot higher than 5, okay? Because 5 hats is only $200, okay? So that's going forward, okay? That gets this number, okay? It's this number here that we need to figure out, okay? So we kind of got to do division, okay? This way we're multiplying, so we need the quantity, therefore we have to divide, okay? Now the reason I say that is, it's no different than going distance equals velocity times time. To figure out the velocity, we would go velocity equals distance divided by time, okay? Right, we got to go the opposite. We got to divide. So, with that said, we take this 2,400 and we divide it by 40 to figure out how many hats, or how many hats are sold. We could do the same thing, guys and gals. We can cancel 2 zeros. Now we just we simplified our fraction a little bit more. We can understand this, right? So again, ignore this 0. Just ignore it. Pretend it's not there. And look at this. 24 divided by 4. Okay, whoops. Okay, so what times 4 equals 24? That's what we want to know, right? Just ignore the 0. Simplify math here. 6 times 4 is 24. So 6 is the number. So if I had to carry this forward, 4 is going to be the meat off the bones. I could show the work the same way, right? We could show the long work times 6, okay? But don't forget this 0. Okay, bring it over. Okay, don't forget the 0. Alright, so cancel the 4s. We're left with 60 over 1. Okay, just to show you it. Over 1, which equals 60. So, therefore you could write kind of like a triangle with 3 dots. Means the same thing. Therefore, Carol sold 60 hats. I'm just going to write it right here. Okay? Carol sold 60 hats. And that's how you do. Okay, I'm going to clean that up. And then I'm going to leave you with another problem for next video. Okay, for funsies. Alright, candy regularly costs $40. Okay, candy. Okay, they're saying it costs $40. Okay, it's kind of a generic thing. We don't know what kind of candy. I guess it doesn't really matter. What is the cost after a discount of 40%? So if you get a discount, the discount is 40%, guys, gals. Okay? If you get a discount, so if you're buying a bunch of candy, regular cost, what would that be called? There, I know there's a terminology for it, but we'll just call it regular. Oh, fit it in there. Okay, and let's say you're, I don't know, you're a consistent customer. You're always buying candy. Whatever you're doing with it, I don't know. Giving it away for free or whatever you're doing with it, right? You're a good person. And you get a discount of 40%, okay? What is the cost? So what is the cost? Okay, what's your cost going to be with the discount? Okay? Good enough. Okay, what's the cost? Alright, I'm going to leave that with you. Okay, I think most of you already may have had it, but that's okay. Alright, give it a try, and I'll do the problem in the next video. Appreciate you watching. Johnny Whiskey Tango. Whiskey Tango sharp. There's no drinking over here, guys, okay? I'm alcohol free. Whiskey Tango is kind of, what do they call that? I know there's a term. Hang on. Lima, blah, 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 blah. What do they call that? There's a term for it. It's kind of like a military thing, right? Just fine. Anyways, you get the idea. Okay, I'm going to leave it at that. That's kind of what it is. Alright. Appreciate you watching. I'll see you guys and gals in the next video. Much love for learning. You're awesome sauceum. Look yourself in the mirror and say, I can do this. Remember, we're going to get you guys and gals to the 120 IQ club. Let's go! Alright. That's it. I'll see you guys next video. Take care. Sometimes I just go on too much, don't I? Later, guys.